Hello. Here we look at the case when the first and second order conditions are not enough to make the conclusion about the point type, whether it is a maximum or infimum or minimum or something else. So as an example, we use this function f of x cubed, and here's its graph, and we are interested specifically in this point where x is equal to 0. A point like this is called an inflection point. It's not a minimum, it's not a maximum, it's a point where the curvature of the function changes. To the right of this point, it is convex, to the left is concave. Okay, so this at this point, concavity changes to convexity. And obviously, it's not a minimum or a maximum point. As before, we see that the derivative here is equal to 0 because the tangent to the graph is horizontal. And if we look at the first derivative, here's the graph of the first derivative, it will be 3x squared. This is a parabola, okay? And we see that the second order condition is also equal to 0. The second derivative is equal to 0 because the tangent to the graph is equal to 0. So what do we do in cases like this? The Taylor approximation tells us what to do. If, as before, we use this kind of approximation with 3 terms on the right-hand side with 2 derivatives, then we see from the first and second order conditions that this and this disappears and the function becomes just a constant. And this information is not enough to establish what happens at this point. So we need to use the Taylor approximation with more terms, which, like in this case, they would include a third derivative. Okay, so if we take into account our first and second order conditions, then from this decomposition we have this kind of approximation that the function around point x naught behaves as x cubed, and we know that x cubed from this discussion, x cubed doesn't have this here minimum or a maximum. And what happens is this is an inflection point, and if we differentiate again this, we see that the third derivative here is not equal to 0. So indeed this will be an inflection point. And in case of say, if now we generalize and consider a case when the third derivative is equal to 0, then we would have to add more terms on the right-hand side and see which term in the Taylor decomposition is not equal to 0, and that term will determine the behavior of the function. Okay, like if here we had an even power like 4, then depending on the sign of the corresponding derivative, whether it is positive or negative, we would have a maximum or minimum. If this power is odd, like it is here, then depending on the, depending on whether this coefficient is 0 or not, we have this inflection point or not. Thank you.